Alright, here we go with homework from section 8.1. Number 2, I know the answers are here, so I'll talk about them a little bit. A simple random sample size n is drawn from a large population with mean mu and standard deviation sigma. The sampling distribution, and this is the distribution of all samples of size n. Well, the center of that, we call it mu sub x bar, is mu, and the standard deviation of x bar is sigma over n, where sigma was the original population standard deviation. So the standard deviation to this sampling distribution is going to be less than the population. Okay, so there's my answers there and there. Number 4. True or false? Is this distribution right here, the sample mean, is that going to be always normal? Or what are the conditions that it has to be normal? Well, the sample mean, or we call it the x bar distribution, or the sampling distribution, is approximately normal if n is greater than or equal to 30, or if the population is normal. If the population is normal, it doesn't matter what the sample size is. Okay, and that is, this right here is called the, it was from the central limit theorem. Okay, I'm going to try to keep that on the screen there. Number 2, 4, 5. The distribution of the sample mean will be normally distributed if the samples obtained from a population that is not normal, regardless of the sample size. That's false. Has to be 30. And number 8. A simple random sample size 40 is obtained from a population with mu is 50 and sigma is 4. Does the population need to be normal for the sampling distribution to be normal? And the answer is no, because n is bigger than 40, right? Or n is equal to 40, which is bigger than 30. And the why, it's because of the central limit theorem, a huge result in statistic land. What is the sampling distribution of x bar? Well, it's normal with mu equal to 50 and sigma equal to 4 divided by the square root of 40. That's my sigma over n right up here. Okay, and it looks like this, right? Mu x bar, sigma x bar. Okay, let's look at 13. It's the following for sampling distribution. The distribution of sample mean shown, the sampling distribution of sample mean shown below. So this is my distribution of all my x bars. The x bar distribution, or like I wrote before, the sampling. In other words, the data points that are on here are averages of all the samples of size n. Okay, so the mean is 500. Sigma sub x bar, well, sigma sub x bar is sigma over the square root of n. That's my formula. But this is the sampling distribution here, and if you remember the distance right out to where that curve changes from being curved down to curved up, that's the distance for the standard deviation. So standard deviation would be 20. Okay, does that make sense? It's 20 each way. C, if the sample size is 16, what is likely true about the shape of the population? Well, since 16 is smaller than 30, there's no guarantee that this distribution is normal unless since it's not greater than 30, unless the population is normal. So since n is less than 30, we have to assume the population is normal. D. Sample size is 16. What's the standard deviation of the population? Well, sigma over square root of n is 20, and they're telling us that n is 16, so sigma over the square root of 16 is 20. Sigma over 4 is 20, so sigma must be 20 times 4, or 80. Alright, that's that, and we'll leave that alone and do the last two on the next video.